Yellowstone Volcano Observatory monthly update for January 2019. This is dated February 1st. USGS. I'll leave a link below for you on this. This is Yellowstone Supervolcano. Recent work and news. The Steamboat Geyser remains active in 2019 with 3 eruptions during the month, January 4th, 16th, and 25th. The latter being one of the smallest based on seismicity and station Y and M, and water discharge measuring at the Tantalus stream gauge since the current sequence of water eruptions began in March 2018. Yellowstone National Park scientists visited Norris Geyser Basin January 30th, and they were able to restart the Norris temperature network, which had been offline since December 20th. Stored data were downloaded, and new data are coming in from all stations, except unfortunately Steamboat, which has been offline due to a faulty data logger since November 2018. We're very happy to be back after the partial shutdown. The federal government, new editions of Yellowstone Caldera Chronicles are being posted each day. Seismicity. During January 2019, the University of Utah seismograph stations responsible for the operation and analysis of Yellowstone seismic network located 84 earthquakes in the Yellowstone National Park region. The largest event was a minor earthquake of magnitude 3.0 located 5 miles south-southwest of West Thumb in Yellowstone National Park on January 23rd at 3:05 a.m. Mountain Standard Time, MST. January seismicity in Yellowstone included a swarm of 12 located earthquakes during January 22nd, 23rd. The swarm events ranged in magnitude from 0.1 to 1.3 and were located 8 miles north of West Yellowstone, Montana. Earthquake swarms like this are common and account for roughly 50% of the total seismicity in the Yellowstone region. Yellowstone earthquake activity remains at background levels. Now, as far as ground deformation, there were no significant changes in surface deformation in the Yellowstone area as recorded by GPS stations. Ground subsidence of Yellowstone caldera continues as it has since 2015 at a rate of a few millimeters per month. In the area of Norris Geyser Basin, GPS data indicate no vertical deformation. The area has shown little net change since September 2018. The Yellowstone Volcano Observatory, YVO, provides the long-term monitoring of volcanic and earthquake activity in Yellowstone National Park region. Yellowstone is the site of the largest and most diverse collection of natural thermal features in the world and the first national park. YVO is one of the 5 USGS volcano observatories that monitor volcanoes within the United States for science and public safety. YVO member agencies are USGS, Yellowstone National Park, University of Utah, University of Wyoming, UNAVCO, Wyoming State Geological Survey, Montana Bureau of Mines and Geology, and Idaho Geological Survey. And the scientists in charge here, as we know, we've read and we've he has given various extensive explanations of what's going on in Yellowstone, is Michael Poland. And now, as far as the Caldera Chronicles go, this is today's article, February 11th, on the Yellowstone Volcano Observatory Caldera Chronicles. Yellowstone Caldera Chronicles weekly column written by scientists and collaborators of the Yellowstone Volcano Observatory. This week's contribution is from Andrew Fowler, Chunyang Tang, and William Sayfield, all researchers of the University of Minnesota. And Andrew Fowler has given us some wonderful images here of the West Thumb hot springs at the bottom of Yellowstone Lake. And I'll leave a link below, you can see them for yourself. Yellowstone National Park, one of the highest concentrations of continental geothermal activity on Earth, and includes extraordinary collection of geysers, acid mud pods, steam fumaroles, and silica deposits. Only recently, however, has the diversity of hot springs activity beneath Yellowstone Lake become appreciated. It is not surprising considering the impressive size of Yellowstone Lake. At about 130 square miles, it's the largest lake in North America, above the altitude of 7,000 feet. This work is thanks in large part to the use of remotely operated vehicles, ROVs, to investigate the lake bottom. Geothermal activity in Yellowstone Lake was reported by the Hydra expedition as far back as 1878 and known about by Native Americans for millennia. Perhaps the most well-known feature is Fishing Cone, a silica cone along the shore of West Thumb that releases warm, salty water with a much different composition than Yellowstone Lake water. However, geothermal activity in deeper portions of the lake has only been studied for the past 20 years, since scientists from USGS and University of Wisconsin-Milwaukee conducted the first ROV-based study of the lake floor. The large multidisciplinary project called the Hydrothermal Dynamics of Yellowstone Lake, HDY Lake, recently completed a 3-year study of hydrothermal vents in the lake. A team from the University of Minnesota has focused on measuring hot spring temperatures and fluid chemistry on the lake floor, while also studying rock and sediment samples. To do this, specially designed samplers and chemical sensors were deployed, much like those used to investigate quote-unquote black smoke or fluids on the seafloor at deep-sea vents. The hottest vents measured during the HDY Lake study were found in the Deep Hole area just east of Stevenson Island. The deepest area of Yellowstone Lake is 410 feet deep, and the hottest vent measured was a whopping 345 degrees Fahrenheit. I mean, that's a very strong oven. This is much hotter than any surface hot spring at Yellowstone because the weight from the overlying lake water acts like a pressure cooker lid and allows temperatures higher than boiling to be reached. Higher than boiling. Indeed, so that's why it turns to steam immediately. Indeed, these are the hottest thermodynamic vents measured in a lake anywhere in the world. The hot water and gas bubbles discharge from small 10 centimeters, that's 3-inch openings in the lake floor, which are very different from the mounds made of silica, like the fishing cone. The water from these vents contains lots of gases like hydrogen sulfide and carbon dioxide, which tells us that the vents are powered by steam. Much like steam-heated areas in the surface in place, like the mud volcanoes in Yellowstone, the lake floor around the deep hole vents is almost entirely made up of the type of clay called kaolinite. Additional details are provided in recent publications. Do seasonal lake level changes affect the temperature and chemistry of the steam-heated deep hole vents? And do the vent fluids respond to seismic events in and around the lake? To answer these and related questions, the University of Minnesota researchers developed underwater sensors capable of logging the temperature and chemical characteristics of the hot spring waters and deployed them for 1 year. The sensors and data loggers were recovered in August 2018 with unexpected results. The high durability PVC data logger for the sensor that was partly submerged in lake sediment well away from an active vent showed evidence of melting, indicating that the high temperatures in the deep hole are more widespread than previously thought. This underscores the challenges of long-term monitoring of hot and corrosive vent fluids. Considering the softening temperature for PVC is about 212 degrees Fahrenheit, it's remarkable that such high temperatures are present in sediment bathed at 39 degrees Fahrenheit lake water. The data logger, however, was complete and has provided important chemical and physical data that is currently under study. In addition to recovering the data loggers from the deep hole, August 2018 work also involved sampling hydrothermal vents in the West Thumb area at a depth of 175 feet. There, the hottest water was a more modest 286 degrees Fahrenheit, which is still much hotter compared to the surface hot springs. Rather than being powered by steam-like vents in deep hole, the water in West Thumb vents is more like the water that deposits silica in many of the onshore geothermal areas in Yellowstone. It's now apparent that the breathtaking range of geothermal features that draw millions of visitors to Yellowstone National Park each year also extends below Yellowstone Lake, forming the most diverse range of lake bottom geothermal features known anywhere. More exciting discoveries and details are sure to come from HGY Lake Project, thanks to support from National Science Foundation through Award EAR and collaborative research. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.